Today we talk about the chain rule, and the chain rule is something that we run into a lot in finding derivatives. It is probably the most common thing that we'll see when we're asked to find a derivative on any future assessment, including the AP exam. And what the chain rule is, well, it helps us find the derivative of something like this. Right now we don't have any tools in our toolbox to find the derivative of the square root of x squared plus 1. And the chain rule gives us the tools to find the derivative of a composition of functions. And this function right here is the composition of, well, this is what's inside, so that would be like g of x, what we referred to as g of x in the past. And this would be f of x. And so here we have the composition of functions, f of g of x, and we'd like to find the derivative of. Well, here's what the chain rule says we should do. If our function is equal to a composition of functions, then the derivative of our function, and I'm going to refer to this as being outside the parentheses and this as being inside. So we're going to have an outer function and an inner function. The derivative will take the derivative of the outer function. Don't mess with the inner function. And then multiply that result by the derivative of the inner function. Derivative of the outer, don't mess with the inner, times derivative of the inner. And so it kind of says that down here. Derivative of the outer times the derivative of the inner. Well, let's see how that actually looks. It helps if we write things with parentheses. Parentheses are going to be a good indicator that we're going to have to use the chain rule. So I'm going to rewrite f of x. And instead of having radical signs are pretty easily replaced with parentheses. So there's our square root. So if we want to find f prime of x, we have to find derivative of the outer, don't mess with the inner, times derivative of the inner. Well, what's outside is this exponent. When we have something to an exponent, what do? Well, we bring that exponent around front. Don't mess with what's inside. And then we decrease that exponent by 1, which makes our new exponent negative a half. Now we've taken the derivative with respect to what's outside the parentheses. Used a power rule. Now let's multiply by the derivative of what's inside the parentheses. And the derivative of what's inside is now, other than cleaning things up, we're done. I think this 2 would cancel with this 2. I think we're going to have a fractional answer because of the negative exponent. So I think the derivative is going to have an x on top. And on the bottom, we can call this x squared plus 1 to the positive 1/2, or put it back under a square root, whichever you prefer. Either way is acceptable. That's the derivative. That is the slope of this function at any value of x. How about this guy? Don't have to rewrite anything. Parentheses were already given to us. We have something on, oh man. We have something on the outside of the parentheses. We got something on the inside. So if I'm looking for the derivative, I'm going to take the derivative of what's outside. Derivative of sine is And don't mess with the inner function. And now let's multiply by the derivative of what's inside. Pretty much done. Personally, I'm a person who wants the coefficients out front. I might call this 2x cosine of x squared. But what we initially had here certainly isn't wrong. It's just my preference to have a coefficient out front. Now, can this get more complicated? Well, yeah, this is calculus. It's what we do. I've said a number of times that whoever came up with this notation just was not a friend of calculus. You look at this and you say, okay, why is that a composition of functions? There's no parentheses. Well, again, if something isn't written with parentheses but could be, it's a good idea to do it. And I said whenever we have a trig function raised to an exponent, it's a really good idea to write that with parentheses. And so this would be the sine of x being squared. So if we want to find the derivative, it's going to be much like our first example where what's on the outside of the parentheses is an exponent. Bring it around front. Don't mess with the inner function. Now to the first power, which we don't have to write, but just for bookkeeping purposes I will. And then let's multiply by the derivative of what's inside. And I think we're done. Now it's possible you look at the solution to this in the homework solutions, and you'll see that James, and I should put a little primed here, that's the derivative. James might write that is a trig identity. 2 sine x cosine x and sine 2x are equal to each other. That was a trig identity he had back in pre-calc. And it is one of only really 2 trig identities that you need to know. The other one being that sine squared plus cosine squared equals 1. Those 2 trig identities. So should you see this as the answer, yeah, it's because it's a trig identity, and it certainly is equal to 2 sine x cosine x. So that's not too bad. Just remember to write trig functions raised to an exponent with parentheses. And chain rule, going to jump out at you because you saw those parentheses. Now, biggest pain. Third slide's always the biggest pain. And that biggest pain comes in the form of chain and quotient. Now I'm going to take this thing down here. I'm going to get rid of the radical sign. I'm going to call it to the 1/2 power. And so if I've got to find the derivative, let's see, I've got to do low. Times derivative of the top, and the derivative of 1 minus high, which is 1, d low. Well, now I've got a chain rule. 1/2 x squared plus x plus 1 to the negative 1/2 times the derivative of what's inside all over low low. Well, low low is pretty nice. The cleanup is a pain. No problem cleaning this up. But what we're going to have is we're going to have negative 2x plus 1. over, see, we're going to have a 2 down there, x squared plus x plus 1 to the 1/2 divided by x squared plus x plus 1. Well, that's a fraction with 3 levels to it, and we said we don't do that. Whenever we run into a fraction that's got 3 or 4 levels to it, we don't divide. We instead multiply by the reciprocal. So I'm going to multiply by 1 over x squared plus x plus 1, which I know is to the first power. No need to really write it, but it does make a point that when I multiply these things out, I'm going to get f prime of x. I've got a top, which is the opposite, 2x plus 1. And on the bottom, what am I going to do with these exponents when I multiply these guys together? I think we'll have a 2 down there. I think we'll have this x squared plus x plus 1. But I think our new exponent is going to be to the 3/2 when I add those exponents together. That's the derivative of this function. That is the slope of this function at any x value using the chain rule. Well, if that isn't fun enough, we got one more slide, the double chain. Now, remember, what is it that signals we're going to use the chain rule? And if you're saying parentheses, you're absolutely right. So what's going to signal that we're going to use the chain rule 2 times? Well, that would probably be 2 sets of parentheses. And here we've got a trig function raised to an exponent. We said best idea in the world to make calculus easier is to take any trig function raised to an exponent, in this case the cosine of x cubed, and move that exponent outside the parentheses. We do see 2 sets of parentheses. We're going to have to use the chain rule twice. The derivative. All right, now what's outside the parentheses is this exponent. So we'll use the power rule. 2. Don't mess with what's inside. Cosine of x cubed, which is now to the first power, which if I choose not to write it is absolutely fine, times the derivative of what's inside. When I look at what's inside, I see another set of parentheses. So I'll have to take the derivative of what's outside, a negative sign. Don't mess with what's inside, x cubed, times the derivative of what's inside. Now that might take a little bit of practice. Double chains are tough. Don't run into them very often, but when we do, recognizing and executing those it's tough. Well, let's pull coefficients out front. 2 times a negative 1 times a 3 is negative 6. I'm going to pull that x squared out front as well. Then we've got a cosine of x to the third, a sine of x to the third, and we've done it. Typically, you'll see a double chain in the no calculator multiple choice section of the AP exam. So let's take advantage of an opportunity to practice some of these skills tonight. And let's get better on the chain rule because it's something we run into a lot.